Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at mole ratio. Now, a mole ratio, when you see the term ratio, this is just another word for conversion factors. Now, a conversion factor between two different substances. Of course, the substances could be an atom, okay? It could be an ions, or it could be chemical formula, or in this case, we better use molecules, okay? So, again, substances. And in this mole ratio, guess what it's going to measure in? It's going to measure in the unit of mole. And we already learned how to convert gram to mole, or the number of represented particles per mole in the previous lesson. Now, where do we get the mole ratio from? And how is that possible? Well, we have learned how to balance chemical equation, and that is using a balanced chemical equation, we can determine the mole ratios based on the different substances in the balanced chemical equation. Another way to get a mole ratio is also using a chemical formula, because in a chemical formula, we have a fixed ratio between the different elements that make up that specific chemical formula. Let's look at an example of balanced chemical equation. In this case, we have 2 hydrogen plus 1 oxygen produce 2 water. Well, we can use this in terms of mole, 2 moles of hydrogen, 1 moles of oxygen gas, and that produces 2 moles of water. So these are some of the possible conversion factors, but there are more, okay? As you can see here, I selectively choose hydrogen and oxygen. And where do I get the 2 and the 1 from? Well, that is your coefficient right here. See that? Right there. And then down here, I have 1 moles of hydrogen and 1 moles of water again. Notice how we have 2 and 2. Well, what's 2 divided by 2? Well, that's simplified equal to 1. Isn't that nice? So be careful with that. If you use 2 and 2, it will still give you the same answer, okay? Now, let's look at chemical formula. In this case, we have ammonium carbonate, and as you can see here, there are 2 ammonium in 1 moles of the whole entire thing. And here we have 1 moles of carbonate equal to 1 mole of the whole entire chemical formula. So that is the basic understanding of mole ratio and how we can get mole ratio from a balanced chemical equation or from a chemical formula. And again, substances could be atoms, which is a specific element, or ions or molecules. In this lesson, we are going to look at how to use the balanced chemical equation to convert from a number of moles of one substance to determine the number of mole of another substance in a chemical equation. So the reaction produced how many moles of potassium chloride from 5 moles of potassium chlorate, or CkLO3, okay? Now, what is our given? So we are given right here, okay? What are we looking for? We are looking for this one right here. So as always, we always start with our given, and as you type in your answer again, we type in normally without any spacing behind it. And we're going to keep our final answer 2 decimal place. So in this case, our given is 5 moles of KClO3. Again, do not space, okay? KClO3. And remember just to type the 3 normally, okay? Now, we look at this. We want to focus on KClO3 and KCl. So we want to circle that, okay? So what's the relationship? Well, what we have here is what? We have 2 mole of KClO3 equal to 2 moles of KCl. And we can simplify that to 1, right? So what do we have to do here? If you want to, you can put 1 or 2, it doesn't really matter. But in this case, I'm just going to put 2 just to show you, okay? So what we have here, KClO3, so we have 2 mole of KClO3. Isn't that easy? So this is on this side, so the other side must be on top. So we have 2 mole of KCl. See that? This cancel out. And what's 2 divided by 2? Of course, it's 1, but you can plug in a calculator. Now let's calculate this with a calculator. Again, multiply everything on top, divide everything on the bottom. So we have 5 times 2, right? And divided by 2. Answer right there. And we want to keep a decimal to 2 decimal places, so be careful. So in this case, 5.00 mole of KCl. There you go. So keep that in mind, okay? We add it in there, just we want to make sure that you know how to follow direction, okay? Keep that in mind. Now let's try another one. In this case, look at this problem. It looks complicated, but it's extremely easy. The reaction needs how many moles of C3H8 to completely react with 18 moles of O2. So again, our given is right here. This is what we're looking for. So we can start with our given. 18 mole of O2, okay? Now let's determine a conversion factor. We're only looking for O2 and CH3, so circle it. Notice how I don't really care about the other substances in the balanced chemical equation. That's why it's important to read the problem. So we have what? 1 mole of C3H8 equal to what? Well, 5 mole of O2. So that's conversion factor. So we look at this. Which one go on the bottom? Well, this is O2, so this one has to go on the bottom. So 5 mole of O2, and the top part must be the leftover. 1 mole of C3H8. Look what happened to mole O2. It cancels out. Now let's use our decimal calculator to calculate it. So we have 18 divided by 5. There you go. And what do we have? 3.6. And we want to keep our answer to 2 decimal places. So we have 3.60, okay, mole of what? C3H8. And that's all we have to do. So that's the process of using a balanced chemical equation to get a mole ratio to determine how many mole to convert the number of moles of one substance to another substance. If you have any questions, definitely take a picture of your work, put in the form, and we will do our best to support you.